Hey guys, in this video I'll show the final project which I worked on for the Fundamentals of Programming course. I made a chess program. You can either play with a friend or play against the AI. So if you play with a friend, you have the option to either play with flip disabled or flip enabled. So if you play with flip disabled, you make your move and then the opponent makes his move, but the board doesn't flip for him to see in his own perspective. You can make your moves either by dragging and dropping your pieces or by selecting the piece and then choosing your destination, and then it moves there. All the standard rules of chess apply, so if I check, you can't make random moves, you have to protect your king, and you can kill pieces and all of that normal stuff. And now let me just show you with the flip enabled. If you make your move, the board will flip, and so both sides can enjoy the game from their own perspective. Now on to more juicier parts. If you play against the AI, you get to play as white or black. So you make your move, the AI thinks and makes its move. You make your move, the AI thinks, makes its move. Move, 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 move. Right now the AI is making fast moves because these are standard moves which it already knows. So the moment I make a move like this, it's not familiar with this position because it's not in the opening table that I provided for it. So that now it will have to analyze the position by itself, think about which move to make, and then make that move. So I'd like to explain to some level of detail how the AI makes its move. So let's assume the AI was white, although it was black just now, let's just assume it was white. And then these are the moves that the white can make, and then these are the moves that black can make in response. So we're just assuming 2 moves per each side, although usually there's around 20 to 30 on average moves that each side can make. And we're just going to analyze to a depth of 2, meaning white makes 1 move, black makes 1 move. My AI right now analyzes to a depth of 3, because any higher would take too long, and any lower would not be a good enough level of play. At the base of each of these, the AI has to evaluate the positions. So the higher the score for each, so each of these gets a score, and the higher the score, the more favorable the position is for white. So you might think white would play this move in order to get towards the 8 position, but that's not the case, because we assume that black will make the best move. So if black were at this position, it would definitely choose this move and not this one. So this position gets a score of 2 for white. And this position gets a score of 1 for white, because if white makes this move, black will definitely make this move in order to minimize the score. Black is actually called a minimizer for wanting to minimize the score, because it wants the position to be favorable for itself. So white will actually make this move because it's 2 here and 1 here, and white is the maximizer. It will move towards the maximizing score. All of that is great, but for my program, the search tree will be very large. So there's 3 main ways in which I minimize the amount of computation required before the AI can make its move. And one of them is alpha beta pruning, which I'd also like to explain because it's something new I learned and I think it's pretty cool. So let's just assume you're a computer and you're gonna evaluate each of these positions. So this position, you evaluated it to be 2. And then the next position, you evaluated it to be 7. So now you know this node has a value of 2, right? Next time that you evaluate the next position here, which is 1, at this very instance, the computer is able to cut off this entire branch of the search tree and not evaluate anything further down here. Why is that? Because white over here wants to make its score the highest, and black at this level wants to make its score the lowest. So at this level, when 1 is evaluated, black knows that the computer knows that black can make the score at least as low as 1. So if this were to be evaluated to be something lower, it would be even worse, and black would have an even stronger advantage here. But already, even if let's say this was something more advantageous to white, black can already guarantee a score of 1 over here. And white would want to maximize its score, so it will not go anywhere where black can guarantee a score of 1. But rather it will move here, because over here white knows it can make the move of 2. So this last evaluation did not need to occur. And this way, by cutting off branches, you make your search tree smaller and easier to search. There's also many other aspects and other ways in which I cut down on the amount of searching. One is, of course, the use of opening books, and the other is basically So normally there's like lots of branches, and each of those branches makes more branches, and a sequence of moves might result in the same position with a different sequence of moves. So every time I evaluate a position, I store the score it gets in a dictionary, so that next time the same position is searched again, its value can be accessed immediately without any further analysis. Finally, I'd like to say there's other aspects of my game. Like, for example, you might be wondering, how is the AI supposed to score each position to find out whether it's more favorable to white or black. So those details you could look for in my code. It's pretty well explained. So yeah, thanks for watching.